Alright folks, on to section 1.6. We're going to talk a little bit about relations and functions. And you guys all know what a relation is, a relationship. It's two things that have some kind of connection, kind of like ice cream and cones. There's a relationship between that. Well, in algebra, we're going to talk about relations between numbers, between inputs and outputs, and then we're going to figure out if that relation is a function or not, and what a function is. So the goal today is to talk about and identify the domain and range of a relation, and then we're going to talk about determining if a relation is a function. First, let's talk about a relation. Here I have a relation, and I'm using this, what we call a mapping diagram, to illustrate the relation. There's a domain here, and we can think about the domain as our input or our starting point. So here we're going to start at 2, and then the range is going to be all of our possible outputs. So our range is the possible output value. So if I start at 2, I can end up at A. And if I start at 2, I can also end up at B. And if I start at 2, I can also end up at C. So there's a relation between the domain and the range. When I start at 2, I could exit at A, I could exit at B, I could exit at C. We can think about these as paths. Like we go to a hiking trail, and on hiking trail number 2, you can end up at location A. We'll call that maybe a waterfall. You can end up at the waterfall. You can end up at location B. I don't know, maybe that's the lookout stone, the lookout cliff. And then option C, if you start at trail 2, you can take trail 2 down to the you take trail C down to the old oak tree. So you can go to the old oak. But it all has to do with where we start at and where we end up. The domain is where we start at, the range is where we end up. When we look at a mapping diagram, we can then create a set of ordered pairs. And there's a relationship between 2 and A. They are related because I can start at 2 and come out at A. There's a relation between 2 and B because I can start at 2 and come out at B. And there's also a relation between 2 and C. Now we show the relation on a mapping diagram with the lines that we draw. Okay? If I just have the mapping diagram and no lines, I can't see the relation. So here I'm showing you that 2 is related to A, 2 is related to B, and 2 is related to C. Again, folks, remember, the domain is the input, the range is the output. So the domain is where we start at, and the range is where we end up. So if I look at this, we look graphically at some relations as well. Here's a relation that is shown graphically. Let's talk about the domain and the range. If I look at the domain on a graphical representation, we're talking about our x values. And we associate the domain and the x values almost all the time in algebra because the x values are our inputs 9 times out of 10. So we're going to talk about the domain as the x values. And then we also have a range, and our range is going to be the y values. Now the first thing we can do when we get a graph and we're trying to find the domain and range is in this one we have individual distinct points. These points are not connected, so I'm talking only about this point and this point and this point, not the points in between them. So the first thing we can do is make a list of ordered pairs. Let's look at this point all the way to the left right here. The x value is -2, -2, and the y value is 1, 2. So there's my first ordered pair. Make my 2's a little better here. The next one, as I go from left to right, I've got -1 and +1. -1, +1. Then I have the ordered pair 0, 0, and then the ordered pair 1, -1, and then the ordered pair 2, -2, and the ordered pair 3, -3. If I needed to list my domain, I could make a mapping diagram. And over here I can make a map, the other part of the mapping diagram. I can have -2 is in my domain, -1 is in my domain. I'm getting these from the x values here. The next one is 0, and then I have 1 and 2 and 3. And in my range, I start back here. My possible y values are 2, 1, 0, -1, -2, and -3. Now, -2, if I input at -2, it leads me to 2. And the relationship for -1 is it relates to 1. 0 relates to 0. 1 relates to -1. 2 relates to -2. And 3 relates to -3. Now, they don't always have to line up directly across. We could cross down here and relate -2 to -3. But if we look, -2 is not related to -3 because there is no point there. So I won't connect that one. Another way that we could arrange our domain, we look at our domain and range, is using roster notation. We list all the possible domain values, -2, -1, 0, 1, 2, 3. And again, because these are individual points, I only want to include these individual points. So roster lends itself nicely to show the domain. There's my domain. And then I could list my range the same way because there's a finite set of points here. I can list 2, 1, 0, but recall, the way I like to do it is always go in alphanumeric order. So I like to go low to high, -3, -2, -1, 0, 1, 2. So we see that the relationship mapping diagram shows me the relationship between my domain and my range directly. The ordered pairs show that relationship directly, but when I list my domain and my range out, I don't necessarily link the first domain number with the first range number. They are just listing all of the possible inputs and all of the possible outputs, not the relationship that is built between them. Here -2 relates to 2. So -2 does not have to necessarily link up with -3 here when I list my range from low to high. Alright, so we've talked about a relation. You understand what a relationship is, but what is a function? Well, a function is a special kind of relationship. So a function is a special kind of relationship. It's still a relation, but we need to talk about what kind of relation it is. The key here is that every input has only one output. So if we go back to my trail discussion earlier, when I talked about taking trail 2, if you wanted to meet your friends out hiking and you told them to take trail 2, would you know where you would end up at, where you would meet them at? No, because you could take trail 2 to the point A, or you could take trail 2 to point B, or trail 2 to point C. So it's not very clear. There's a little bit of confusion. There's one start point, but 3 possible end points. So it's not a function. So what would make a function? Well, let's talk about another example here. If that is not a function, if I have the relationship from dad to children, let's say that each of these dads has 2 children. If I made the comment, hey, dad 1's child is great, would you know who I was talking about? No, because if I start talking about dad 1, it leads me to 2 possible results, Bill and Jen. So this is not a function because for one input, dad 1, I have 2 possible outcomes. It's not clear. I can't identify the specific child. Same thing for dad 2. There's 2 possible children. But sometimes if we switch the domains and ranges, if I make my input value the child and my output the parent, Now if I said Bill's dad is the greatest dad in the world, well, if I start at Bill, whose dad do I come out with? Where do I come out at? There's only one dad that I can come out at. So this is a function because each of my inputs, or my domain, has only one output. If I tell you Jen, you know exactly which dad I'm talking about. Jen only leads to one dad. If I'm talking about Sarah, it only leads to one dad. Now, realize that I can't have one input leading to two outputs and have a function. But I can have two different inputs going to the same output and have a function. And we can think about what we'll talk about a little bit later, a parabola, a quadratic function. If this is the point 1, well, it's going to have an output for 1 at two different points. So I could input, let's say it's x squared, I could input 1 and get 1 out, or I could input -1 and get 1 out. Even though I can start at two different places and end up at the same location, there's only one output. If I go to -1, the answer has to be 1. If I go to 1, the answer has to be 1. So there's no confusion when I start with the x value, what y value I'm coming out at. So now let's put this into practice. Let's look for a minute. We'll use some mapping diagrams and some ordered pairs to talk about the inputs and the outputs. So we've given you mapping diagrams, and the question is this a function or is it not a function? So let's look at my mapping diagrams here. Remember, our x values are going to be associated with our domain, and our y values are going to be associated with our range. So we have our domain and our range. Let's look at the domain values here. -3. For it to be a function, my input can have only one output. Well, how many outputs does -3 have? It only leads to one value. So that one's good. My input can only have one output. -2 only leads me to 3. So I'm still good. 1 only leads to -2. And 5 only leads to 3. So the domain here has a single relationship to the range. There's only one output for every input. When I start at -3, I only come out at 0. When I start at -2, I only come out at 3. So this is a function. Now let's look at this next relation, still a relation, but is it a function? When I start at 7, does it only lead me to one value? Yes, 7 only leads me to 3. There's no confusion. If I said start at 7, you're going to end up at 3. Now if I said start at 6, you know you're going to end up at -1. Now if I told you I want you to start at 4, what's my answer? What's the output if we start at 4? Now there is a bit of confusion because I could start at 4 and end at 2, or I could start at 4 and end at 5. There are two outputs for one input. This is not a function. Again, the key here is 4 goes to two different values. Now if I list out ordered pairs, what can we do with that? Well, to make it easier, we could make a mapping diagram. And inside that mapping diagram, I would order all of my x values from low to high. What's my lowest x value? -4. And then my next, and I'll keep consistency here. We'll put this in red. What's my next x value, or my next domain input? I've already got -4 there, so I don't have to worry about that anymore. The next one would be 2. I've got 2 of those, but I only need to list them one time. 2. And then the next one would be 4. And the next one would be 6. I've got all of my domains. Now this is my outputs, my range values. My lowest value is -4. There's 2 instances, but I only need to list it once. My next value is 2. There we go. And my next highest value is 6. So now let's analyze and see if, now that I've made sure I got all these things, let's compare the relationships. The relation, see if it's a one input leads to one output all the time. If I start at 6, I can lead to -4. If If I start at 2, I can lead to -4. Now that's okay because 2 is only leading to -4. Even though these both lead to the same number, when I start at 6 right now, I'm only going to -4. -4 can lead to 2. Still no problems. Every input only has one output. 4 can lead to 6. Still, every input has only one output. Now 2 can lead to 6. And there's an issue. When I look at -4, it only leads to one output. When I look at 4, there's only one output. When I look at 6, there's only one outcome. But when I look at 2, it leads to 6 and to 4. There's confusion. If I start at 2, I don't know where to end up at. So this is not a function as well. So looking at the numbers using ordered pairs or mapping diagrams, we should be able to find a function. A function has, for every input, it leads to one output. Every input has only one path off of it. So for it to be a function, every input has only one path. If any input has two paths, it's not a function. Let's talk graphically. There's an easy way when we look at a graph, and here we have continuous functions. They're going on forever. They're all connected, so it's not separate little points here. We can actually draw a curve through them. There's a way to tell if each x value has only one output. Well, it kind of makes sense because if I go to any particular x value, let's just go to -3. 1, 2, -3. What's in the output value? -4. Is there any other output for -3 but -4? No. There's only one output, so that one satisfies it. But I don't want to sit there and do this for every single point. And there's something called the vertical line test that can do it a little simpler and gives us a good visual. If I could take a vertical line and only touch one point on the graph at a time, I'm only catching one y value for every x value. Again, at -3, my output is -4. There's no other point on this line that is output at -3. If I only touch a graph at one point with a vertical line, it is a function. So this guy is a function. For every input, there's only one output. Let's try this next one. For every input, there's only one output. I'm only touching the graph. I'm only touching that red line with my black line one point at a time. I never touch the line twice at the same time. So this guy is also a function. Now let's look at this next curve. As I go from left to right, I'm not touching anything. And now, look, if I go to x equals 1, what are my possible outcomes? My possible outputs are, at 1, I touch this graph at a y value of -1 and also a y value of +1. So if I looked at my input of 1, it leads to 1, it leads to -1 and 1. So for one input, I have two outputs. This is not a function, and it fails the vertical line test because this vertical line is touching the graph in two places at a time. It touches in two places at a time. So let's try this next one. And this one is not a continuous function. It has a break here, but there are points to show me everywhere the function exists. Or correction, the relation. We have to test and see if it's a function. So this relation is out there. I need to see, it's not a continuous curve. There's not a line connecting everything. But let's see if it is a function or not. Well, here it seems good. I'm only touching one point. Here I'm only touching one point. If I come to the other side, I'm only touching one point, one point, one point. But what happens when I get to x equals 1? Remember, a solid dot means I'm including this point. So at x equals 1, I have two possible outcomes. I could be -2. So I'm 1, I could be -2 or +2. Because for one input, I have two outputs, this is not a function. So a quick 30-second recap. We've talked about relations. And under relations, we've talked about domains, which is our input. And we associate domain with our x values on our coordinate plane. And we've also talked about ranges, which is our output, which we can associate with our y value. We can list the domain and range for a finite set using roster notation. And then we can compare the domains and range to see if something is a function or not. If it is a function, then there's only one output. If it's a function, there's only one output for every input. So wherever I start, where I start at, it only leads me to one result.